A warm welcome to who are all present here. Myself, Jayalakshmi Saravanan. I am Assistant Professor in Department of Data Science from IFT College of Engineering. I am really happy to present about detection of COVID-19 using denoising autoencoders and Gabor filters.
The most basic and effective response technique in emergency departments is early isolation of potential patients through early detection. Chest radiography or CR is a quick and low-cost imaging modality that can be used for detect abnormalities in the lungs. With traditional PCR testing, most countries have failed to bridge the gap between the size of the epidemic and the size of the monitor. As a result, CRG and CT scan reports are used to diagnose the disease with the help of artificial intelligence. Artificial intelligence. In the medical industry, it focuses on the processing and the evaluation of large data sets to assist physicians in making better decisions, efficiently handling patient data, designing customized medicine programs for complex data sets, and developing new medicines. The term artificial intelligence refers to the intelligence that robots can demonstrate as opposed to natural intelligence that humans and animals can demonstrate, which includes awareness and obsessiveness. The use of artificial intelligence in medicine has resulted in the development of complex algorithms that streamline the performance of specific tasks. When academics, medical professionals, and other scientists feed data into machines, newly developed algorithms analyze, categorize, and in some cases even suggest solutions to complex health problems. Then, chest radiograph, CRG. The purpose of a chest radiograph, often known as a chest X-ray or chest film. It is used to identify illness that affect the chest, its contents, and adjacent structures. The most frequent type of film taken in medicine is a chest radiograph. Chest radiographs are used to diagnose a range of conditions affecting the chest wall, including its bones, as well as the lungs, heart, and main blood vessels in the thoracic cavity. Congestive heart failure and pneumonia are two conditions in chest radiographs is routinely used to diagnose. Chest radiographs are also used in industries like mining, where workers are exposed to dust to screen for lung conditions brought on by the environment. So here we use chest radiograph for the analysis of the lungs. And computer tomography scan. A computer tomography scan, often known as CAT scan or computer actual tomography scan. It is a medical imaging procedure that produces precise inside pictures of the body. To measure the attenuations of X-rays by various tissues inside the body, CT scanners employ a revolving X-ray tube and a row of detectors arranged in a gantry. The tomographic reconstruction procedures are then used to analyze the many X-ray data acquired from various angles on a computer to create tomographic cross-sectional pictures, virtual slices of a body. Patients who need a CT scan but cannot undergo an MRI do so because they have metallic implants or pacemakers. So, it gives more information about injuries or diseases of the chest organs. So, we consider to use this computer tomography scan for detecting COVID-19 which is affected in lungs or not. Then, the existing framework. Here we take 4 existing frameworks. The first one is deep coronet. The limitations of the deep coronet are, in this method, they use the MCWS algorithm, which lengthens the computation time. And a deep LSTM based solution unavoidably needs a lot of memory bandwidth for practical implementation. And second one, deep belief networks. Here the two-dimensional structure of an input picture is not taken into account by DBNS, which has a substantial impact on the efficiency and application of these algorithms in the context of computer vision and multimedia processing problems. Third, multilayer perceptron. The lack of a sufficient sample size causes this analysis to have a serious problem. Also, using the AI model to screen COVID-19 patients produced encouraging results. More study is needed to discover whether the AI model can be used to screen patient groups outside COVID-19 patients. The tiny sample size also causes issues with model training. The last is local binary patterns. It produces extremely lengthy histograms which slow down recognition, especially when working with huge databases. And they ignore the regional structure and in some cases fail to take the middle pixel's potential effect into consideration. They produce sensitive to noise binary data. So, these are the limitations that we found in existing frameworks of the detection of COVID-19 in lungs. And the proposed framework. There are two key parts make up the planned system. The first one is denoising autoencoders and the second is Gabor filter. Using denoising autoencoders to eliminate picture noise and the Gabor filter to extract features. Well, an alternative to the standard autoencoder is the denoising autoencoder. The denoising autoencoder seeks to randomly tamper with the input data. The output of the autoencoder, a convolutional layer, is comparable to the raw data, while the decoder recreates the original input values. The encoder converts the data into hidden representations. Then it is a representation of the denoising autoencoder structure. Here you can see in the screen, and there are three primary parts to it. One is encoder, encode, and decoder are their names. To decrease picture noise, the algorithm has several hidden layers in denoising autoencoder. Gabor filter. It is a linear filter used for texture analysis and image processing. It simply determines if the picture contains any certain frequency content in particular directions in the confined region surrounding the point or region of examination. Here we go to see the architecture. You can see that is a X-ray of human lungs. When we use a denoising autoencoders, it reduces noise and the segmentation are given. With the help of the Gabor filter, we can easily simplify if there are any certain frequency in particular directions or something. And the denoising autoencoders is used to noise reduction. As we see, the Gabor filter is used for feature extraction, and hence it gives the result if the person was affected by COVID-19 or not. And the outcome, first, overall performance. Test images for the proposed implementation included 168 COVID images and 1596 non-COVID images. Well, the results of the suggested implementation were assessed using FN score, precision, recall, sensitivity, accuracy, and specificity. Then the data sets for training. The provided chart shows the precision, recall, and FN score that were acquired after training a data set. It is challenging to train since COVID-19 has a little amount of data set accessible. To do this, the combined data set was randomly split into train, validation, and test sets with a ratio of 1, 0, and 0.96. The last one is data analysis. Here you can see the data representation, the graphical representation. Well, the provided graphic displays the results of the training data set's final data analysis. Recall is 0.86, but the accuracy and FN score remain at 1. COVID-19 positive, normal, and other pneumonia affected photos make up the total data sets in this representation. And last, I concluded that the suggested method or our proposed method has an accuracy rate of 98.5%. Additionally, the proposed approach may be used to swiftly diagnose individuals with COVID-19. The COVID-19 epidemic must be managed, stopped, and the communication lines must be broken with the help of our proposed system. Thank you.